Okay, section 3.3 is intersection and union of two sets. So basically what we want to do in this section is we're going to figure out what does it mean if you have a union or if you have an intersection of sets. So a couple of definitions here. The intersection is a set of elements that are common to two or more sets. So in set notation, A and then kind of that upside down U, B denotes the intersection of sets A and B. For example, if A is 1, 2, 3 and B is 3, 4, 5, then A intersect B is 3. So the key word for intersection is that they have to be common. Union, then, is the set of all of the elements in two or more sets in set notation. So A with the kind of right side up, U, B denotes the union of sets A and B. So for example, if A is equal to 1, 2, 3 and B is equal to 3, 4, 5, then A union B is equal to 1, 2, 3, 4, 5. So you think of union like a marriage. When two people get married, all of their stuff that they have gets joined together. Except for money. Your money's your money. So union is all of the elements. So principle of inclusion and exclusion. The number of elements in the union of two sets is equal to the number of the sum of elements in each set less the number of elements in both set. So using set notation, this is written as number of A union B is equal to the number in A plus the number in B minus the number in A intersect B, or A and B. So if you think about this logically, what they're saying is you take whatever you have in set A and whatever you have in set B and you add them together, but you have to take away the stuff that they have in common or the stuff that overlaps, because otherwise you'd be adding that twice. So if you take a look at the diagram here, if this is my set A, the red set, so if I did A plus my blue set B, and if I added those both together, then I've added the stuff that's in common between the two of them twice. So I need to take one of those sets away. So in set notation, A intersect B reads as intersection of A and B. It denotes the elements that are common in A and B. The intersection is the region where the two sets overlap in the Venn diagram. So the union of A and B is denoted, it denotes all elements that belong to at least one of A or B. The union is the red region in the Venn diagram, so it's everything. A and that backslash B, or is that a forward slash? Forward slash B is read as A minus B, and it denotes the set of elements that are in set A, but not in set B. So it is the red region in each Venn diagram below. So if we look at the first one, A minus B, when B is a subset of A, so B is part of A, but B only contains this one blue region of A, not all of it. So A minus B, when they are disjoint sets, would look like that. They'd be two separate circles with nothing in common. They're not overlapping at all, or intersecting at all. And then the last one there is, excuse me, A minus B when they intersect. So when they have that little bit of an overlap, then again the red area is the A minus B area. So just a few things to keep in mind when we're going through these, when you're going through the questions. So Venn diagrams and notations. So we're going to shade the regions that contain the elements that belong. So the elements for A would be all of that. The elements in set B are those. Elements of A prime then. So that's everything that is not in A. So everything not in A is going to be this, along with everything that is on the outside. everything's not in B then. So B prime, that's the way that's read. So B prime is anything that is not involved with the B set. So that's going to be everything in the A that doesn't overlap and everything outside. A union B. So remember that A, or the union of A and B, means that you're bringing everything together. Union means or. So everything that is in A or B is everything in A and everything in B. So A union B, or union of A and B prime, means that everything that is not in A or B. So that's then going to be everything on the outside here. Oh, I better change my color there. Oops. Keeps giving me a highlighter. I just want a pen. So everything not in A or B is then just everything that is on the outside here. So intersection of A and B is what this example is. And remember that there stands for and. So this is what's in A and in B. Well, that's just our little section in between here. The intersection of A and B prime means everything that is not in common with those two. So that's going to be everything except for that intersection part. So it's going to be all of this. So your middle overlap is what is going to stay there. A minus B. So what's in A but not in B? That's this section here. Okay, if you look back at our definition here, A minus B, it denotes a sort of a set of amounts that are in A set but not in B set. So A minus B, so it's everything in that, everything that is in the A but not in the B. B minus A, so that means everything in B but not in A. So this was in A but not B, and this is in B but not A. So it's just that part of the circle there. Okay, so let's apply this to some examples. So it says determine the union and intersection of disjoint sets. So if you want a little bit more background of it, I put the page number there. It's on page 164 in the textbook. So it says if you draw a card at random from a stack of cards, you will draw a card from one of four suits: clubs, spades, hearts, or diamonds. So it says describe sets CSHD and the universal set H for this situation. Or sorry, the universal set U for this situation. So a universal set U would be drawing a card for this situation, right? Drawing a card from a deck of 52 cards. Whoops, deck of 52. Subset S then. S is for spades. So that would be drawing a spade. So the situation for the heart would be if you were drawing a heart. Club then is drawing a club. That would describe the situation, and then the diamond, of course, is if you were to draw a diamond out of the deck. So the next part, the B part, says determine the number of each of those sets. So remember to show that in notation, you put a little n, and then you put in the letter that is going to stand for whatever set you're talking about. So for the universal set, that would be 52. For our spades, the number of elements in spades, that's 13. Number of hearts is 13. Number of clubs, excuse me, is 13, and number of diamonds is also 13. So C part says, describe the union of S and H, determine the number of the union of S and H. So remember, union means or. The union of spades and hearts then. So just to describe that, S union H, or the union of S and H, would be the set of 13 spades and 13 hearts. So the union then, or the number of elements of the union of spades and hearts, is the number of spades plus the number of hearts, which would be 13 plus 13, which is 26. Now I wrote this out in fairly basic steps. You won't need to do that, but I just want to show you when you get to doing some other questions that aren't going to be as basic or as simple as the card drawing one. That's where you would get your, if you want to call it a formula. So the union formula is just adding your two sets of elements together. So it says describe the intersection of spades and hearts. Why does that say it twice? So intersect, sorry, not union. Describe the intersection of spades and hearts and determine the number of spades and hearts. So the intersection of spades and hearts, so that's saying how many cards can you draw that's a spade and a heart. Remember, intersection means and. So that would be the empty set, because you can't draw a spade and a heart. So the number then of elements in that intersection is 0. So it says describe or determine whether the events that are described by sets S and H are mutually exclusive and whether sets S and H are disjoint. So between S and H we can have a union, but we do not have a situation where we can draw a spade and a heart. So that means that the event of that happening, of you getting a spade and a heart, are mutually exclusive. It means one can't, or they both can't happen at the same time. You'd have one or the other. Okay, so a card cannot be so therefore the events are mutually exclusive. So are they disjoint? Well, they are disjoint because disjoint means they don't have anything in common or that there's no overlap. So spades and hearts would be a disjoint set. So they're disjoint sets because there isn't any overlap. So the complement of spades union heart, or of the union of spades and hearts. Remember, complement means what's not in there. Complement is not. So the complement of S, of the union of S and H, or spades and hearts, could be described as the set of cards that are not hearts or spades. I'm going to cram that in there together. So S union H complement then would be the set of clubs with the union of diamonds. So example 2 says the athletics department of a large high school offers 16 different sports: badminton, basketball, cross-country, running, curling, football, golf, hockey, lacrosse, rugby, cross-country, skiing, soccer, softball, tennis, ultimate, and I think this was supposed to be ultimate frisbee, volleyball, and wrestling. So they want us to determine the number of sports that require the following types of equipment: a ball and an implement. So something like a stick, a club, or a racket. Okay, so they have to, this is an intersection one, so it's a ball and a piece of equipment to go with it that you need to hit with. So what we need to do then is we need to draw our Venn diagram. We're going to say, where's my... I'm going to have one set here and one set here. Oops, I might have to make those a little bit bigger. You gonna let me? Oh. No. I'm just gonna pause so I can make my, there we go. I want to make that a little bit bigger. And I want to make that a little bit bigger. Okay. Just so that I can fit my words in there. Okay. So our universal set is going to be the set of everything. The ones that require a ball will denote with a B, and an I for the ones that need an implement. So we'll call this set B and this set I. So if we look at badminton, badminton uses an implement, but it doesn't use a ball. So that's going to go here. Basketball uses a ball only. Cross-country running uses neither. Hurling requires an implement. You need a rock. Football is a ball. Golf requires a ball and a club. So golf would go in here. Hockey requires a puck and a stick, but it's not a ball, so that goes under the implement. Lacrosse uses a ball, and I can't remember what the lacrosse stick is called, but it would be considered a, I don't know if they call it a stick, I guess. Rugby just uses the ball. Cross-country skiing requires implements. You need the skis and the poles. Soccer is a ball. Softball requires a ball and a bat. So that's an implement. Tennis requires a ball and a racket. Oops, can't spell tennis. Ultimate frisbee it's not a ball, and it's not an implement because it's not a stick, so that one we'll put here. Volleyball requires a ball. And then finally, wrestling, you don't need an implement or a ball. Okay. So, we set up our Venn diagram, and then we take a look at our elements for each. So the number in the ball that require a ball was 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of elements in the implement were 1, 2, 3, 4, 5, 6, 7, 8. And then the number that was in the intersection of the ball and the implement, oops, my board just has to catch up, is 1, 2, 3, 4. And our universal set, of course, if we wanted that one, it said that there were 16 sports. So the number that require only a ball. Wonder if this will let me move it down so we can. That's not what I wanted to move. Oh, it won't let me. Okay. And let me do this. There. So the number that require only a ball. So that's the same as saying the number that is in the ball minus the implement. So to figure that out using a formula, if you want to call it, we'd say the number that are in the ball minus the number that are in the ball and the implement. So number in the ball was 9, number in the ball implement was 4, so only a ball would be 5. Now, you can look at this and say, okay, but I could just count these. There's not that many you could count them, and you can. This is just to show you how the formulas work, when you're going to work with ones where you don't have the time to count them, or there's too many to count, or they've already set up the stuff for you, and instead of doing all of the other work, you can just use it'll give you the numbers, and you can just use your formulas, if you want to call them that, in order to solve it. So the number that are either a ball or an implement, so remember, or means that you're doing union. So number that is a ball or an implement. So remember from that first one that you're taking the number that is a ball plus the number that is or are an implement, but you have to subtract the ones that are in both because you're going to do it twice. So number in the ball was 9, number in the implement was 8, minus the number that are in both. So 9 plus 8 is 17, minus 4 is 13. So the number that are an implement but not a ball. So this is the number that's an implement but not a ball. So that's the number that are implements minus the number that are in implement and ball, or ball intersect implement. So number in implement is 8, number in both is 4, so that's 4. And then the last one, neither a ball nor an implement. So I'm doing the number of B, so nor is the same as R, union I with that complement or the prime. So that's the number that are in the whole universal set minus the number that are in either one. So that's 16 minus my n from here is 13, so that's 3. So this is just to show you how to solve using our different terminology. Okay, the principle of exclusion and inclusion. So the number of elements in the union of two sets is equal to the sum of the numbers of elements in each set less the number of elements in both sets. So that's what we've been doing. When you want to find out how many are in a union of sets, then you have to add up both of them minus what they have in common. So that was our little formula like this. Number of elements in A union B is equal to the number in A plus the number in B minus the number in A intersect B. So it says subtract the elements in the intersection so they're not counted twice. Once in NA and once in NB. So this is what we would have. It would look like this, A and B. And that colored part, if we took them apart, would be here. Looks like a bad set of eyes. And also there. So that's why we have to subtract it once, so that we're only counting it once. If two sets A and B are disjoint, they contain no common elements. So this is what we're looking at. If we have set A, and this is set B, and the number of elements in A union B, because there is no overlap there, so A intersect B means there's no overlap, so it's 0. But if we're looking at the number of elements in A union B for a disjoint set, so even if they have nothing in common, you're still combining them, you're joining them, that's what the union means. So it's be the number of A plus the number in B. Example 3 says, Jamal surveyed 34 people in his gym. He learned that 16 people do weight training 3 times a week. 21 people do cardio training 3 times a week, and 6 people train fewer than 3 times a week. How can Jamal interpret his results. So first we need to do is we need to set up, okay, what are we going to use for our sets? What's going to represent our sets? So if we say G is the number of people that he surveyed at his gym. We'll say W is the number who did weights 3 times a week. And C is the number who did cardio 3 times a week. Whoops. Oh, and those should be curly brackets. Okay. So to start with, we know that there were 6 people that trained fewer than 3 times a week. So we know that starting at if there's 34 people in total, and of those 34, 6 of them didn't do this 3 times a week. So that means that we have 24 people that we're left with who do this at least 3 times a week. Not 24, 28. Sorry, can't subtract. So that means the number of that do weights or cardio is 28. So what we need to figure out then is how many then, because we could draw our Venn diagram for this, but we don't know how many are in that overlap spot. So that's what we need to find. How many do weights and cardio 3 times a week? So the way that we're going to figure this out is by using our union formula. So we would have the number of people who do weights or cardio is equal to the number who do weights plus the number who do cardio minus the number that do weights and cardio. So if I look at my information that I have, I know that the number that do weights is equal to 16, and I know that the number that do cardio is equal to 21. So if I put in my known facts here, the number that do weights or cardio was 28. The number that did weights was 16. Plus the number that do cardio was 21. Don't know this. So I have 28 is equal to 16 and 21 is 27 minus weights or cardio. Sorry, weights and cardio. How about if I use a 37? Boy, my math is bad today. 37 there. So in order to solve for this, if I bring my 37 over, I'm going to have negative 9 is equal to negative of that. Get rid of my negative, so it's just 9 is equal to the number who do weights and cardio. So now, because I have that information, I can set up my results to interpret this. Okay, so this is my universal set at 34. I call this side my weights and this side my cardio. I know that my intersection here is 9. So that means that number that do weights alone is then going to be the number that did weights was 16. I just want to write this, so to get my number in here, I know that this has to be 16. So if there's 9 there, that means that I would have 7 here. For the number that do cardio altogether, there was 21. So if 9 of them do both, then that means of those 12 need to be doing cardio only. So if you add your numbers up there, 7 and 9 is 16, and 12 is 28. And then I have my, what was it, 6 people? Yeah, 6 people out here who don't do anything, or don't do it at least 3 times a week, so they would do it less in there. So that's what my Venn diagram would look like. Okay, so the summary of the key ideas here, the union is all of the elements in at least one of the sets. It is represented by the entire region of these sets on a Venn diagram. It is indicated by the word or. Okay, so you can have a union in either way. They can be disjoint or they could be overlapping. The intersection of 2 or more sets, for example, A intersect B, or the intersection of A and B consists of all the elements that are common in both of those sets. It is represented by the overlap and is indicated by the word and. So when you have an overlap like this, then the gray part there is what's in common. When there is no overlap, then you won't have an intersection. So the last part there says you need to know if 2 sets A and B have something in common, then the number of elements in A or B is the number in A plus the number in B minus that overlap. This is called the principle of inclusion and exclusion. So to calculate the number of A union B, subtract the elements in the intersection so they are not counted twice. So because otherwise if you did, you'd be counting this gray area once and then you'd be counting it again. If 2 sets A and B are disjoint, they contain no common elements. So intersection B would be 0, but A union B would be adding both of those together. Elements that are in a set A but not in set B are expressed as A with that slash B, so that means A minus B. The number of elements in A or B, number A union B, can also be determined as follows. The number in A but minus B plus the number in B minus A plus the number in A intersect B. So it's just a different way of writing it and getting the same answer. So there's your questions. Good luck.